Today we are going to study Aldol condensation. In this video we are going to understand the mechanism and the application of Aldol condensation. So first we study what is Aldol means, what is condensation, why its name is Aldol condensation. So in this condensation, first reactions between an aldehyde or ketone forms a beta hydroxycarbon. So what does condensation mean? If the two molecules combine with the loss of a small molecule, generally in aldol condensation we lose water when two molecules combine. So its name is aldol condensation. Why is aldol? Here an aldehyde from an ald plus ON, ald from an aldehyde and hydroxyl group present, so its name is aldol condensation. So after the dehydrations of the hydroxy group, it forms a alpha beta unsaturated carbon. So generally the aldol condensation possible in two medium like basic medium and acidic. Generally we use in basic medium. So we in the both case we found the same product, but in base catalyzed aldol reactions, it gives aldol product or dehydration undergo through E1CB mechanism and in acid catalyzed medium undergo through E1 mechanism. This is the difference. Then we are going to see the general scheme. What is the general scheme? So one forms enolate ion and one reacts as a electrophile. So this is the general scheme. In the next slide, we are going to understand this. So this is the mechanism in basic medium. First, we are going to know enolate formations. So this is a aldehyde. This is for acetaldehyde. So we take a weak base. So in the last, we are going to see why we use a weak base. Okay. So base first one here acidic hydrogen. So it takes the acidic hydrogen and forms an enolate. Then in the second step see we say that there is a new CC bond formation occurs. How the O minus negative in the enolate comes and forms a double bond O, and this double bond attached to this electrophilic center so that it forms a new CC bond. Then protonation occurs. So in this medium where stored present, then this O minus takes the H and gets protonated and removal of OH minus occurs. And this is aldol bond formation occurs. One is carbonyl group and one is hydroxyl group. So its name is aldol. In next step, dehydration occurs means condensation. In which a small molecule present. In this case, water is going to form. So this O minus comes and forms double bond to the double bond shifted to here and finally water removal occurs. This is called condensation and this is called Aldol. So its name is Aldol condensation. So in this condensation, what we get? Alpha beta unsaturated carbonyl compound. Then we are going to show what is the conditions and how does aldol condensation work. So first, aldehyde must be an alpha hydrogen so that the base abstract the alpha hydrogen and forms an enolate. And in this case, the enolate acts as a nucleophile because here is a minus that comes to the form double bond O and it acts as a nucleophile. And also there must be an electrophilic center so that the enolate nucleophile adapt to the electrophilic center and forms a carbon-carbon bond formation. And for condensation, there will be hydroxy group so that removal of water occurs and it forms final product as a alpha beta unsaturated carbonic group. Generally, weak phase used in aldol condensation. Why we used weak phase? Weak phase forms only a small amount of enolate. So weak phase, in this case, weak phase forms only a small amount of enolate, and the remaining aldehyde molecules act as electrophiles. If we give a strong base, then what happens? All the molecules of aldehyde or ketones forms enolate, so there will be no electrophilic centers. Then there cannot be formed is carbon-carbon bond formation. So no aldol condensation reaction occurs. Okay, so remember this: we aldol condensation we used weak base. Next, we are going to see what are the types of the aldol condensations. Aldol condensation are generally two types: intermolecular and intramolecular. Okay? And intramolecular has two types: self-aldol and cross-aldol. In self-aldol condensation, what happens? Aldehyde or ketone is same molecule, one molecule that forms enolate and that also acts as an electrophiles. In cross-aldol condensation, one molecule forms enolate and another molecule acts as electrophile. And the other condensations have many applications in extra product synthesis and also in formations of ionic molecules, drug molecules, pharmaceuticals. Okay. In next video, we are going to see what is intermolecular and intramolecular. We are going to discuss about more in the next video.